just a couple doors down from my office. And I said, look, we've got a huge problem. He said, no.
That was recently discovered in our galactic neighborhood. Erica Byfield reports.
I can't stop thinking about this. And once you hear what the James Webb Telescope just spotted, you won't either. This discovery is so wild that scientists question everything they thought they knew.
Nobody really knows where the name Black Knight satellite came from. We can't find where the reference suddenly came into Black Knight.
A mysterious alien megastructure, something straight out of science fiction, has appeared in deep space, and experts are scrambling to figure out what it really is.
The best wildlife documentaries it's when the animals don't know you're there.
Let's get into it. Well, who would have thought naughty ancient Incan chords would make a comeback in space? Enter Quipu, the largest cosmic structure we've ever seen, stretching a jaw-dropping 1.4 billion light-years and boasting about 68 galaxy clusters. The astronomers couldn't have picked a better name, given that this beast resembles the intricate, thread-like appearance of a quipu, those knotted cords used by the Incas for keeping records. The path to this discovery kicked off with good old Rosat, the German X-ray satellite launched way back in 1990. Tasked with scanning the heavens for X-ray emissions, Rosat played the long game, collecting data that would later reveal the secrets of galaxy clusters sprinkled across the universe. Fast forward a couple of decades, and you have scientists like Dr. Hans Boehringer from the Max Planck Institute for Extraterrestrial Physics poring over this cosmic treasure trove. They meticulously mapped out a three-dimensional spread of the nearby universe, identifying clusters within a spherical shell that spans 416 to 826 million light-years. And just like that, Quipu, stretching from high northern to nearly the southern end of the sky, made its grand entrance, knocking the previous record holder, the Sloan Great Wall, off its 1.1 billion light-year pedestal. This isn't just about breaking records, though. Quipu reshapes our understanding of the cosmos. Think of it. These gargantuan structures are more than just cosmic eye candy. They hold a significant chunk of the universe's mass, molding the galactic spread and the very fabric of the cosmos. For eggheads like Dr. Boehringer, these are not just points of light. They are the landmarks that help us measure everything from the Hubble constant to cosmic microwave background radiation. Getting to grips with these superstructures sheds light on the universe's very essence, its evolution, and how everything we understand about space might just be part of a much larger pattern. It's the sort of discovery that underscores not just the power of modern telescopes and satellites, but the magic of global teamwork in peeling back the layers of the universe's deepest mysteries. Now, you might find it hard to believe, but back on Earth in 1899, the legendary Nikola Tesla was onto something possibly otherworldly in Colorado Springs. While fiddling with his equipment, he picked up some bizarre radio signals. Now Tesla, being Tesla, speculated these were not just random cosmic chit-chats, but might actually be intelligent Martians trying to ping us. He noted these as faint signals that seemed to represent a numerical code. Fast forward to today, the consensus in the scientific community leans more towards these signals being natural cosmic radio emissions from pulsars, celestial bodies that weren't even on the radar back then. But why let facts get in the way of a good mystery? Enter the conspiracy theorists who have latched onto Tesla's Martian Morse code as proof of the Black Knight satellite, a supposed alien tech piece orbiting Earth. And oh, the tales they weave are as sticky as cobwebs in an old attic. This lore gets thicker with a dollop of intrigue in 1928, when Norwegian engineer Jürgen Hals got into the mix. He reported a head-scratching phenomenon, long-delayed echoes, LDEs, where his radio signals took a leisurely round trip, returning after several seconds. While some chalked it up to reflections from the moon or distant atmospheric layers, the Black Knight enthusiasts saw it as a cosmic game of ping-pong with an alien satellite. The plot thickens in the 1950s, with UFO researcher Donald Keyhoe stirring the pot. He claimed the U.S. Air Force had spotted 2 satellites ghosting Earth before Sputnik ever beeped its way into orbit. Though these tales were probably more about selling his UFO books than solid facts, they kept the dinner party debates lively. Then, in 1960, the US Navy spotted an unidentified dark object in orbit, which turned out to be a mundane piece of the Discoverer 8 satellite, much to the dismay of extraterrestrial enthusiasts. The saga peaked during NASA's STS-88 mission in 1998, when astronauts snapped pics of an irregular dark object. While some shouted "Black Knight" from the rooftops, NASA played party pooper by explaining it was just a lost thermal blanket. But why let go of a juicy alien conspiracy theory just because of a little space litter? Now, if your head isn't spinning from all this space drama, let's zoom way out to something truly mind-boggling. Just this past December, astronomers were eyeballing the Quasar 3C273, which is lounging around in the constellation Virgo, a casual 2.5 billion light-years from your backyard telescope. Virgo is a historical icon, being the first quasar ever identified back in 1963. Despite its fame, the darn thing is so bright it usually overshadows anything in its cosmic vicinity. That's where Bin Ren and his team from the Côte d'Azur Observatory in France come into play. With the help of the Hubble Space Telescope's Space Telescope Imaging Spectrograph and a clever trick involving a coronagraphic technique to tone down the quasar's glare, they've peeled back the celestial curtain to reveal a few surprises. Imagine being able to see what's essentially invisible. Around this supermassive black hole, the team spotted a peculiar L-shaped filamentary structure and several blobs of varying sizes, all hanging out within a cozy 16,000 light-year radius from the black hole. These structures are thought to be the remnants of small galaxies. Snacks, if you will, for the quasar's insatiable appetite. It's like catching a glimpse of the crumbs left over from a cosmic feast. Ren himself couldn't help but marvel at the find, noting the assorted sizes of the blobs and that mysterious L shape, which could be a crucial clue in unraveling the quasar's eating habits. This isn't just about adding a new photo to the cosmic catalog. The implications are massive, like black hole massive. These observations might just help us piece together the puzzle of how supermassive black holes and their host galaxies interact, particularly through the messy process of galactic mergers. And let's not forget the style points for Hubble here, bridging the gap between small-scale radio interferometry and grand-scale optical imaging, letting astronomers take a closer look at the quasar host morphology. What's next? Well, the team's already eyeing the James Webb Space Telescope to dive even deeper into this mystery in different wavelengths, promising even more revelations about the nature and origin of these enigmatic structures. Just when you think space has shown us its best, it whips out another ace, like the nearly perfect Einstein ring discovered encircling the galaxy NGC 6505. This discovery came about during the European Space Agency's ESA Euclid Space Telescope's initial testing phase in September 2023. Galaxy NGC 6505 is precisely what Albert Einstein's general theory of relativity predicted could happen. Light from a distant galaxy gets bent and magnified by the gravitational field of a massive object in the foreground, painting a stunning celestial ring for us to gawk at. This cosmic phenomenon provides a peek into the universe's dark side, dark matter and dark energy, that is. Launched just a couple of months earlier, in July 2023, with a little help from NASA, the Euclid mission had one fancy goal: to explore the dark universe. It's out there mapping the mysterious spread of dark matter and dark energy. And let me tell you, the fashion discovery of this Einstein ring, that's like finding the perfect pair of shoes that go with everything. It not only flaunts Euclid's high-end observational skills, but also offers a sneak peek into how galaxies are holding all that cosmic clout, including the elusive dark matter. Here's where it gets a bit whoa! Euclid archive scientist Bruno Altieri caught a glimpse of this Einstein ring during the telescope's camera check. He saw a hint of it in those initial snaps from September 2023. With a few more peeks, bam! There it was. A perfect ring around NGC 6505, which is not just any galaxy. This one's lounging about 590 million light-years away in the constellation Draco, acting all mysterious with light from an even more distant galaxy, about 4.42 billion light-years away, wrapping around it due to gravitational lensing. And NGC 6505 isn't some new kid on the block either. It's been in the cosmic yearbook since 1884. Yet, despite being a known face in the galaxy lineup, its Einstein ring was playing hard to get until Euclid came along. ESA Euclid Project scientist Valeria Pettorino put it quite poetically, marveling at how this well-acquainted galaxy threw a surprise party with its new ring. It goes to show that even old guards like NGC 6505 have a few tricks up their sleeves thanks to Euclid's sharp eye. The real kicker: when scientists took a closer look at this stylish ring, they figured out that about 11% of NGC 6505's central swagger is thanks to dark matter. It's like discovering the secret ingredient to your favorite cocktail. This insight is not just about having a new piece of cosmic jewelry to show off. It's a critical clue in understanding the galaxy's evolution and structure. Now, from peering into the depths of space to gazing at the brightest star in our night sky, Sirius, also known as the Dog Star, commands attention. Known since ancient times, this star is the brightest one we can see from Earth. But hold on to your telescopes, because the tale of Sirius and its secretive companion, Sirius B, is where things get really juicy. In 1844, German astronomer Friedrich Wilhelm Bessel noticed something fishy about Sirius. It wasn't just shining bright, it was wobbling a bit too. Bessel threw out a wild idea. What if Sirius wasn't dancing solo? What if it had an invisible partner pulling its strings through gravitational force? Yes, he dared to suggest that Sirius might just be a part of a binary star system. Fast forward to January 31st, 1862, and enter American telescope maker and astronomer Alvin Graham Clark. While tinkering with a new, beefy 18.5-inch refracting telescope in Cambridgeport, Massachusetts, Clark spotted a faint point of light lurking near Sirius. And bam! He discovered Sirius B, the hypothesized companion hiding in plain sight. This wasn't just any discovery. Sirius B turned out to be the first white dwarf star ever identified. You could say Clark had a real star moment. Now, despite sharing the spotlight, Sirius B is no easy star to study. Being a white dwarf means it's a dense little leftover of a star that's run out of nuclear fuel. It's like the tiny but tough sibling of Sirius A. It took until 2005 and the power of the Hubble Space Telescope for astronomers to really get the measure of this star, confirming its mass and securing its status in the Cosmic Hall of Fame.
The moment we saw this, we went from cautious to...
Meanwhile, out beyond the familiar boundaries of our solar system, whispers of a Planet 9 began to stir in 2016. Astronomers Konstantin Batygin and Mike Brown from Caltech presented some intriguing evidence suggesting there's another planet out there playing hide-and-seek with us. They called it, quite aptly, Planet 9. This elusive giant, estimated to be about 10 times the mass of Earth, is thought to cruise on an orbit around 20 times farther from the Sun than Neptune. That's a chilly 56 billion miles away. Imagine this distant traveler taking its sweet time, about 10,000 to 20,000 years, to complete just one orbit around the Sun. Now, how did we stumble upon even the idea of this cosmic heavyweight? Flashback to 2003, when Mike Brown and his team at Caltech turned the astronomy world on its ear with the discovery of Sedna, an oddball object way out in the Kuiper Belt. That's the chilly ring of debris that circles our solar system like a frosty halo. Sedna was weird, mainly because its orbit didn't make a lick of sense if you only consider the gravitational tug of the planets we already knew about. Then, fast forward to 2014, and along comes another strange object, 2012 VP-113, sporting its own set of bizarre orbital dance moves. Driven by curiosity and a dash of scientific bravado, our intrepid astronomers crunched numbers, turned to detailed mathematical modeling, and revved up their computer simulations. Their detective work paid off, suggesting that Planet 9, with its hefty mass, could be the puppet master behind the strange ballet of these Kuiper Belt objects. The beauty of this theory? It ties up the loose ends of those elongated, peculiar orbits with a nice little bow. Despite the slick theoretical groundwork, Planet 9 is playing hard to get. No one's actually seen it yet. It's so far away that it barely catches any sunlight, making it a tough target even for the most powerful telescopes. But fear not, the hunt is on. Astronomers across the globe are scouring the skies with gadgets like the Zwicky Transient Facility and eagerly awaiting the Vera C. Rubin Observatory's grand debut. They're combing through mountains of data, trying to spot any faint, slow-moving objects that might be our elusive Planet 9, making its ghostly rounds in the solar void.
The idea that there could be a giant planet that we'd never seen is something I think most of people wouldn't have bet on. But the evidence is remarkable.
Just when you thought space couldn't get any weirder, in October 2017, Robert Warwick, a sharp-eyed researcher at the University of Hawaii, caught a glimpse of something truly bizarre while peering through the Pan-STARRS 1 telescope at the Haleakala Observatory. What he spotted wasn't just another space rock cruising through our solar system, but the first ever recorded interstellar visitor, dubbed Oumuamua. Now, Oumuamua isn't your garden-variety asteroid or comet. Nope. This thing is straight out of an interstellar playbook. Detected a mere 33 million kilometers from Earth, this object was hustling through space at a pace that made heads spin in the astronomical community. Its trajectory was hyperbolic, which is science speak for "I'm just passing through and won't be sticking around," confirming its origins from beyond our solar system. Imagine the excitement. This was like catching a rare bird mid-migration. It was only way cooler because it was from another star system. Astronomers quickly noticed that Oumuamua wasn't behaving like the typical comet that lights up with a gas and dust coma when it swings by the sun. It remained as stoic as a lone ranger wandering through the cosmos, leading to some head-scratching about whether it was an asteroid after all. Measuring about 400 meters in length and sporting a reddish color, it resembled a giant cosmic cigar from a distance, another tick on the list of its oddities. In the wake of Oumuamua's flyby, telescopes worldwide tuned in, eager to catch a glimpse or glean some insights. Even NASA's Spitzer Space Telescope joined the party, trying to spot it in infrared to figure out just how big it was or what it was made of. Alas, it remained elusive, hinting that it might be smaller or weirder than we first thought. The cherry on top? Its name, Oumuamua, means scout in Hawaiian, symbolizing its role as a messenger from the distant realms of space. It's a fitting name for something that has opened a whole new field of study: interstellar objects. Thanks to this intergalactic nomad,
charge of coordinating the observing to characterize the object.
We're now peeping through our cosmic windows more eagerly, hoping to spot the next visitor from afar. Speaking of peeping, 2021 brought its own cosmic spectacle with the discovery of the Perseus-Taurus supershell. It's a giant spherical void, about 500 light-years across, hidden between the Perseus and Taurus molecular clouds, like a cosmic secret waiting to be spilled. This epic find was spearheaded by a sharp team from the Center for Astrophysics, Harvard and Smithsonian. Big kudos to Dr. Shmuel Bialy and Dr. Catherine Zucker, who made this discovery with the help of the Gaia Space Observatory. Gaia's been our cosmic cartographer since 2013, mapping the Milky Way in 3 dimensions with an accuracy that's just chef's kiss. So, what's the big deal about finding a space cavity, you ask? Well, using a nifty piece of software called GLUE, these researchers mapped the Perseus and Taurus clouds in 3D, revealing this colossal void that had been hiding in plain sight in 2D maps for ages. Dr. Zucker shared her excitement, noting, "For decades, we've seen these clouds, but had no idea what was really going on with their shape, depth, or distance. Thanks to their 3D magic, they've nailed down these structures' distances and relationships, showcasing the undiscovered grand void. Now, about this void's origin, imagine the fireworks of supernovae. Not just one, but possibly a series lighting up the sky between 6 and 22 million years ago. These starry explosions hurled energy across space, forming this super shell we're gawking at today. Dr. Bialy gave us the scoop, saying it might have been one mega supernova or a blockbuster series over time. The aftermath? Those shockwaves probably kicked up the dust and gas, leading to the birth of new stars. Dr. Bialy summed it up beautifully. This shows us how the death of stars isn't the end, but a trigger for the next generation. This isn't just about stargazing, it's a look at the life cycle of stars and how cosmic events are all interconnected. And with the precise data now in hand, Dr. Zucker points out, we can pinpoint their locations with only 1% uncertainty, revealing the vast void that separates them. Seriously, hats off to these cosmic detectives for giving us a front row seat to the ongoing drama of the universe. Speaking of intriguing cosmic phenomena, back in 1950, Arthur Allen Hogue stumbled upon something unusual. While surveying galaxy clusters, Hogue bumped into a celestial oddball in the constellation Serpens Caput. It was a nearly flawless ring of hot, blue stars circling around a cozy core of older yellow stars, all separated by a mysterious, dark void. It was so unusual that Hogue went ahead and documented this find in the Astronomical Journal, floating ideas like maybe it's a planetary nebula or some quirky galaxy. He couldn't quite pin down what it was, but dubbed it perfectly symmetrical, and thus Hogue's object got its name. In the early days, tools to decode such cosmic puzzles were pretty basic. Hogue toyed with the idea that this ring-like appearance might be due to gravitational lensing. Think of it as cosmic light bending because of a massive object in the foreground. But that idea got tossed out when it turned out that both the core and the ring shared the same redshift, meaning they were both part of the same big space ensemble. Later peeks through more powerful telescopes showed the ring had a knotty texture, not the smooth arcs you'd expect from lensing. Fast forward a couple of decades, and thanks to better tech, astronomers got a clearer view. Studies from the 1970s confirmed Hogue's object wasn't just a fluke, but a bona fide galaxy. Its origins? Still up for debate. Theories floated around like maybe it was the aftermath of a galactic collision eons ago, or perhaps a wild spin-out from a barred spiral galaxy going haywire. Despite the head-scratching, this galaxy, chilling about 600 million light-years away and stretching some 100,000 light-years wide, yep, that's Milky Way territory, has become one of the cosmic paparazzi's favorite subjects. Its almost perfect ring structure is a visual treat, and if you look closely, right through the gap at about 1 o'clock, you can spy another faint ring galaxy peeking back at you, adding an extra layer of cosmic intrigue. And while we're gazing up at the wonders of the universe, let's tip our hats to the astronomers who, in 2014, introduced us to the Laniakea supercluster. This beast of a structure is like the New York City of space, spanning over 500 million light-years, and home to around 100,000 galaxies, including our very own Milky Way. The name Laniakea, which sounds as enchanting as the place itself, means immense heaven in Hawaiian. This nod to celestial navigation celebrates the Polynesian navigators who explored the vast Pacific using nothing but stars. These astronomers were kind of like the celestial cartographers of our time, mapping the unknown terrains of the universe. Leading this starry expedition was R. Brent Tully from the University of Hawaii. He wasn't alone in his cosmic voyage, though. Joining him were Hélène Courtois of the University of Lyon, Yehuda Hoffman from the Hebrew University of Jerusalem, and Daniel Pomered of CEA Université Paris-Saclay. This dream team wasn't just stargazing. They were on a mission to redefine our understanding of the universe's structure. They dug into the Cosmic Flows 2 survey, which is as cool as it sounds, compiling detailed info on how galaxies move and where they chill out in the universe. Analyzing over 8,000 galaxies, they discovered these galaxies were not just randomly drifting. Oh no, they were all being pulled towards a mysterious point known as the Great Attractor, a gravitational boss of sorts that commands a cosmic meetup. Using some serious computer wizardry and brain power, they mapped out this galactic get-together, finally outlining the immense scale and contours of Laniakea. And when they published their findings in the prestigious journal Nature, with a paper boldly titled The Laniakea Supercluster of Galaxies, it wasn't just another publication. It was a declaration that changed the map of our universe. As if 2014 wasn't enough of a cosmic roller coaster, let's fast forward to February 2025, where astronomers are at it again. This time, they're peering into the Oort cloud, that mysterious, icy shell of debris that encircles our solar system way beyond Pluto. Turns out, the inner part of the Oort cloud isn't just a cosmic junk drawer, but has a snazzy spiral shape, sort of like a mini galaxy, tucked around our solar system. Now, for those who might not be up on their space lingo, the Oort cloud is massive. We're talking stretching from 2,000 to maybe 100,000 times farther than the cozy Earth-to-Sun stroll. It's the kind of distance that makes even NASA's Voyager 1 look like it's crawling. It takes about 300 years to hit the inner edge, and, a casual 30,000 years to cruise through. So you won't be visiting anytime soon. Here's how they cracked it. A team led by the astronomer David Nesvorny, a real Sherlock of space stuff, took NASA's Pleiades supercomputer for a spin. This beast of a machine can crunch numbers like nobody's business. They set it up to simulate all those comets zipping around out there, plus the gravitational tug-of-war with our galaxy, the Milky Way, which they call the galactic tide. And what do you know? Turns out this galactic tide is the cosmic sculptor that's been secretly shaping the inner Oort cloud into this swanky spiral, about 15,000 times the Earth-Sun gap. Believe it or not, this whole spiral shindig likely kicked off early in the solar system's playlist, just a few 100 million years into the track, and it's been holding its twist despite all the celestial hustle and bustle like stars cruising by. Now, while we're on the topic of space oddities, let's take a quick peek at another celestial wonder. In 2003, the star-studded runway featured a young star named AU Microscopii, AU Mike, wearing a dazzling dust disk, first spotted by astronomer Paul Kalis and his sharp-eyed team. Using the University of Hawaii's 2.2-meter telescope perched on Mauna Kea, they caught a glimpse of something spectacular. AU Mick, a sprightly 12 million years young and chilling about 32 light-years away in the constellation Microscopium, was not just another twinkling in the night sky. This stellar youngster, much younger than our seasoned sun, was encircled by a dust disk extending from about 50 astronomical units, AU, to a whopping 210 AU. Just for scale, 1 AU is the comfy distance between Earth and the Sun, so imagine a cosmic catwalk stretching beyond Pluto's orbit in our own solar system. This wasn't just any disk. It hinted that AU Mike might be in the midst of throwing a planetary party, with new planets possibly forming around it. In 2004, Kalas and his colleagues hit the academic airwaves with their findings in the journal Science. They describe this disk as the closest example of a debris disk, a primo pick for understanding how planets get their groove on. Observations revealed that this disk was more of a minimalist, being gas-poor, with a gas-to-dust mass ratio barely hitting 6:1, a far cry from the primordial expectation of 100:1. Think of it as a gathering of dust from cosmic car crashes, comets, asteroids, you name it, smashing and crashing in young AU Mike's orbit. Zoom ahead to more peeks through the Hubble Space Telescope, and the plot thickens. Its advanced camera for surveys showed us that from our earthly lounge chairs, this disk looks edge-on. It even flaunted a cleared region about 12 astronomical units from the star, a possible VIP section where new planets might be swirling into existence. The disk's overall vibe was intriguing, marked by asymmetries and features that could be the signature moves of unseen planetary bodies playing gravitational tug-of-war. Then, in 2015, the plot took a twist with astronomers at the Very Large Telescope, VLT, in Chile spotting something truly wild. Wave-like features were seen surfing through the disk, rushing away from AU Mike at breakneck speeds of up to 10 kilometers per second. That's about 22,000 miles per hour, in case you're counting. These ripples in the cosmic pond are like nothing we've ever seen in a debris disk before, making AU Mike not just a pretty face, but a mystery waiting to be unraveled. What a universe we live in, where even stars have their secrets. What more do you think could be out there, or something we can't even begin to comprehend? Drop your thoughts in the comments. I need to hear what you think. If this blew your mind as much as it did mine, don't forget to smash that like button, subscribe for more mind-bending space discoveries, and hit the bell icon so you never miss an update.